So like what is the reason when we rub two objects, exchange of charge takes place?
Now see, as I said before, it became vacancy there. Loss of electron. It is losing some electron. And we are assuming that there was some charge in balloon. We don't know whatever it is. And
Yes.
woolen was also having some charge. So it gave some charges to them. That is electrons. So it transferred some electrons to that balloon. So balloon became negatively charged now. And wool became positively charged because it gave excess electrons and balloon gained excess electron.
Yes.
So extra electrons, it makes him negatively charged particles. Became negatively charged. And wool becomes positively charged. Now, what is this called? That this is the first part that is called by friction, by rubbing.
So like one more thing, sir. If
Yeah.
I apply a charge, if I rub a charged particle against an uncharged particle,
Okay.
then
And
what
it
will
will be.
happen? So like
This
what
will.
kind of
Now it will. This good question. It will have. What will happen that time? It will be equally balanced charge now. They both will have equal charge now. If this is a charged particle, let's assume that some Q, and here it is uncharged particle. Okay. So when we are rubbing this one to this one, so this will be now Q by 2, and this will be also Q by 2. It will be equally divided then because it's totally uncharged. Nothing is he's having.
Okay, sir.
Yes, sir.
We gain some because it's losing some. It's gaining some. Okay. So this was by friction. Next. By conduction. Have you heard this term conduction?
The property of transfer of charges.
Yes. This all are transfer of charge. Friction is also transfer of charges. Conduction is also transfer of charges. What was the difference here?
So like in conduction, the charge transfer from molecule to molecule. Yes.
Molecule to molecule, okay. So if I give you a simple example, when I'm standing near the door and once I touch that door and I open it, and in that, suppose if there is it's charge, static charge or whatever charge it is. Okay, so I'll feel that shock a little bit, right?
Yeah.
I'll feel the shock instantly. Once I touch it, once I touch the doorknob, I'll feel it. Why? Instant the transfer of electrons take place. Are you able to understand what I'm saying?
Yes, sir.
What's the question here? A person suppose you're walking on some carpet. Anyhow, everywhere there will be carpet. So a person walks across carpet and touch doorknob. What will happen? Gets electric shock. Let's say why. Can you give me some specific reason?
So let charge transfer.
Charge transfer. Yes. But what's the reason of this carpet here? I added here carpet, walks across a carpet and touches the doorknob and gets electric shock. It won't be
So
that
like,
much deadly, but okay. We can feel that.
so like there is this transfer of charges from carpet as well as the door. From two ways you're having the charge.
Okay, yes. That's true. Anyone else want to share your idea? Come on, this is open discussion. Come on, try something. What's the reason behind this? Try something, come on.
Like we act as a medium for
Yeah.
door and carpet.
Exactly, we act as a medium.
We as a medium for door and carpet.
Yeah, doorknob and carpet.
We act as a medium for that.
So what's happened when we do this? Just electrons transferred instantly. Say electrons instantly travel from carpet and so who is that person, right? Electrons are instantly transferred from carpet and person gains what? What charge? Person gains
negative charge.
exactly negative charge. Now he gained negative charge. Then when he touched the doorknob, when he touched the doorknob, what will happen then now?
The electrons will transfer from the person to the doorknob.
Exactly, instantly. Say again, instantly this thing happens. So electrons jump onto his hand when he touches doorknob. Electron jumps onto his hand. This is known as discharge. This is known as electric discharge. So when he touched the doorknob, electron jumps onto his hand. That is discharge. Okay, so here's some question by Deepshika. It is what? Atoms never touch each other, but we are made up of atoms. So do we never really touch anything? See, if we see that way, yes, we are made up of atoms, correct. Yes, there is a tiny particle. Okay. And when we are touching anything, yes, it is the atom is touching another atom. I am holding a pen right now. This is my writing pen. Okay. So I'm holding some material. That is, material is made up of some other atom. So we are touching some atoms. Okay.
But the atoms can't really touch each other, right?
We are touching each other, right?
Yes, sir.
See, are you holding a pen right now?
Yes, sir.
Exactly.
Okay, sir.
ठीक है? Okay, this process is what we were discussing when you just now you asked me, right? I think so. Who was that? Kavya asked me, right? When uncharged body, what happens? This is what it happens.
Yes, sir.
So let's write few points. What we wrote here, let me think. Like a person while walking across the carpet and touch the doorknob gets electric shock. Why? So electrons instantly travel from carpet and a person gains negative charge. And when he touched the doorknob, electrons jumped onto his hand and it got discharged. So that phenomena is called electric discharge. So in this process, or let's say some other way, when uncharged body becomes charged, when it will become charged when a charged body brought near it, right? Or charged body brought near a contact. When a body is brought in contact with it, it means uncharged body. Okay, so from this one, from whole whatever we wrote these things, what we are concluding, what is conduction? We wrote so many points. Instead of that, I want one line. What do you mean by conduction? If I ask you, how will you give one line answer?
Instant travel of electrons from one object to another.
Exactly, instant travel or direct transfer of charges. Don't say electron, let's say charges. I did positive charge particle or negative charge particle. Yes, correct. Very good. So let's write a summary of this topic. What is it? Conduction is the process of instant transfer or direct transfer charge. When you're writing this, highlight this point. Right now, whatever we are studying, it's about electrostatic. Even we didn't start our electricity. We are in electrostatic. Electrons still for us, electrons are still steady. They are not moving. So once electrostatic completes, we will, okay, now electron moves. Then we will say electron move. That will give you what? Electricity. Okay. Clear with this one, everyone? Conduction? Everyone?
Yes.
Anyone doubt?
No doubt, sir.
No doubt, sir.
No doubt. What about others? I have 20 members here.
No doubt, sir.
No doubt, sir.
Okay. Still some more.
No doubt, sir.
No doubt, sir.
No doubt.
No doubt, sir.
No doubt.
Okay. Ritvik, Sai Charan,
No doubt.
Udbhav,
Sir.
Modita,
No, sir. No doubt.
Yeah, sir, I understood. Yeah, sir.
super. No doubt. Okay, fine. Okay, then let's go with some more point what we wrote here. Let me check. Okay, friction we wrote, conduction we wrote. Next is induction. Have you heard this term induction? Have you heard this term induction? Induction cooker or induction stove?
Yeah,
Induction.
sir. I have already in my kitchen.
Right. What do you mean by if you have seen that induction stove or induction like gas or whatever it is, it's not gas, just a machine which works on electricity.
It converts electricity to heat.
Yeah. So if I ask you one question, does it physically touch anything?
Yes, sir.
Is it touching? Think again.
So like it's kept in a utensil and then kept there.
But that is just for holding things. Okay, let me show you one utensil. It's fine. Let me induction stove. Yeah, I got it. I don't want shopping image. Now, when you see this one, something they are preparing, whatever it is. Okay. So actually, this is just for holding, but that coil which is there inside induction coil is actually touching this person or this thing. Let me change color. This induction coil which is there like this, is it touching this vessel? Is it touching?
So you mean the cord which is connected to the switch?
Yeah,
No, sir.
it's not actually touching. If I show you proper way, wait. Where's the coil? Yeah, I got it. Perfect. Photograph. Yeah. But it is the term which is mentioned here. It's not for you, but still we will see that. Now see this coil. Observe this coil. This coil is not touching it. It is just a surface which is holding the appliances, whatever appliances we have. It is just holding it. But due to its heating, due to this heat, it is just a portion of that part is heated. Okay, due to induction process. Now, what do we observe here without touching? So can we make one statement? One statement. Induction will be the process for what?
Object not in contact.
Without in contact. Without, if we specify without in physical contact.
Okay. Yes, sir. What do you mean by eddy currents?
These terms we are not going, because it's still needed to learn so much before that.
Okay. Yes, sir.
That's why I say like these terms, we don't go with these terms. Not required these terms. I'll talk about this one later. Don't worry, we'll discuss everything. Okay. Now let's write some points about induction. So let's make similar way. It's a process of getting charge without any physical contact. The object is charged without any physical contact. To any other charge object. Then how does it get charged and how does it get discharged? Here comes the question, like, correct? We are saying it's not physically touching, then how it get charged and how it get discharged? Can you think of it? We are saying object is charged without any physical contact to any other object. Okay. We are saying that, fine. But why? How? Not why, how? Yes? Yes, Harini?
It may be charged.
I'm sorry, I didn't get you. Can you be a little bit louder?
Can you hear me now?
Yeah, I can.
I'm saying that by heat energy it can be charged.
Yes. Correct. Very good. Due to transfer of heat. Okay. So if I write in some words, the charged body or object does not transfer electrons. Does not transfer or receive. Both. Or receive from other charge. Let's write this much. does not transfer or receive. Now, here comes a new term, that is polarization. Because this is totally based on polarization. Okay, this is about totally based on polarization. Now, if I ask you simple terms, have you heard this polarization? Have you heard this term?
No, sir.
No. Okay, see, in detail we'll discuss later, but I'll give you a small idea about it. It is just dividing into like two groups or some groups. It's just dividing into groups. Simple terms. If I go in some detail, like because we haven't studied so much in this one. Okay, let's make it simpler. Suppose when two sides of object gain some charges. Okay, two sides of object gain some charges. Means this is our object. It gains some charges, some opposite charges. So we can say that this object became polarized. So what will happen when we are what will happen if object is having positive and negative charge? What will happen? Can you
It
think
will
of it? Yeah, it will
attract, I guess.
just attract.
So it will have potential difference also.
Yes,
High voltage.
exactly. So when we place near a negative charge, it will attract this side. When we placing negative charge here, it will repel. So it will behave both way. So that will create a potential difference. That we'll study later. We are not going to that thing now. So when two sides of object gain some opposite charges, the object is polarized. So that means what? Polarized means the whichever object is closer by, the closer side will get attracted and farther side will get repelled. Okay, so let me show you one more thing, a photograph. Wait, which is, I think so you know already. Okay, just I'll paste one photograph. You just see and tell me what is it. Have you seen this picture anywhere or similar thing?
Like the top positive part is trying to attract some negative charges,
Yes.
and there are some positive and negative charges at down.
Okay. So what will happen there?
Then the top and bottom will repel, I guess.
Okay. No. Then let me show you one more picture. So do you know the name of this thing? Paste one picture. It is called electroscope. Okay. So when you see here, it is cardboard covered here. And it is metal ring. Simple. I'll give you a simple terms about this one. What is it? See, like, no need to go in detail about this one. Simply, like when it is nearby, when it gets charged up. Okay. So this gold foil, it's here. It's aluminum. Sometimes it is gold they are using. Gold foil or aluminum foil electroscope, gold foil electroscope, whatever it is. So they'll move away. So we can understand, okay, this is positive charge or negative charge. Even it is negative charge nearby, it will move or repel. Okay. Here in this case here, if you observe this one, this is positive charge. So we are bringing near positive charge ion or rod and it starts repelling. This is for gold.
I didn't understand this one, sir.
Sorry?
I didn't understand this one, sir.
Okay. Let me make it more simpler. Okay, this electroscope is specially for finding what type of rod has charge. I mean, what is the charge of the rod to find that? So when we are placing this aluminum foil or aluminum leaves or foil, whatever. So when we are bringing the charge rod, we don't know what charge it is. So to understand what is the charge of that, we are using electroscope and we will place near it this metal clip. When it is touching that clip, it will start moving away or moving together. See, without touching, it was like just holding here. See that? And it moved away. Can you see the difference?
Yes, sir.
Okay. It shows that it is positively charged. The rod is positively charged.
So why can't it be negative? Like if both are negative, they will repel again, right?
Then it will come nearby. That will move nearby.
If negative, it will come nearby.
Yeah, opposite direction.
Okay. Sir, but light charges repel, right?
Yeah.
So but how can then
No, not that way. Light charge is repel. We are not saying that. This is just to determine, okay, what is the charge of this rod? That's it.
okay.
So
Yes, sir.
foil will move away here. In this case, see, this is for gold. The negative charge rod was placed here, so it started moving away. So it shows that this rod is negatively charged.
Okay, sir.
Yeah.
Sir, can I repeat again?
Yeah. Okay, then let me just show you some other way if you're not able to understand. A sphere I'm placing here, which is neutral. Let me check there is a picture of this one, then I can paste. It will be easier. Yeah, this is better. Okay, this will make you understand better. So this one, a metal pan. This is positively charged about aluminium and gold, whatever we are using, depends. See, if it is placed nearby, it will show this negative because it will get repel here, move away. It will show positive when it is negatively charged. It will repel, we can say it's positively charged when it is negatively charged. Cap. In short, we are talking about cap here.
Okay, sir.
And this thing will determine by this foil will determine whatever foil we are using, it determines that it's positively charged and negatively charged with the help of this metal cap. Clear now?
Yes, sir.
100% or somewhat?
Clear, sir.
Achha. What about others?
Clear, sir.
Yes, sir.
Achha. Okay. Somebody said something. Achha, okay. It is just simple to determine what charge it is. That's it. Okay. Then let's go for properties of charge. Can someone name properties of charge? What are properties of charges?
It's like light charges repel and unlight charges attract.
Exactly.
And sir, the charge is conserved.
They are conservative, yes.
And also
And also,
one second, something.
okay, fine. So first is charges are additive in nature. So what do you mean by additive nature? What do you mean by additive in nature?
The gain and loss.
Simple, not gain and loss. Additive. What do you mean by additive?
Adding.
Exactly. That means total charge of a system is equal to algebraic sum. Total charge of system is equals to algebraic sum. Suppose, example, let's say there is a charge which has plus 7q, another charge which has minus 4q. So what will be total charge?
3G.
But here I said additive in nature. Then why you are subtracting?
Say it's minus.
So like we are taking 4 charges, right?
Yes.
So that's why.
So we are just adding only. This charge is having negative charge. Okay. So we are just adding. Yes,
7
add.
plus minus 4.
Yeah. Plus minus 4. We are just adding. But it has negative. That's why we got as 3q. So net charge is 3q. Okay. Second, charge is conservative or conservation of charge. As you already mentioned, what do you mean by charge is conservative?
Like total charge is always conserved.
Exactly.
Charge cannot be created, not destroyed.
Total charge of isolated system means closed system remains what?
Conserved.
Yes, or constant. So if we give a definition of this one, charge can neither be created nor can be destroyed, but it just can transfer from one object to another object. Same as conservation of energy. Okay. So conservation and additive nature, no doubts, right? Do we have any problem in this one? Any doubt in this one? Am I audible? Okay. Kavya, are you using mobile phone?
No, sir, my brother is using. He's sitting beside me.
Acha, acha. Next is quantization of charge. This is new term for you?
Yes, sir.
Acha. This means what? Quantization means it is an integral multiple of it. So I think so you know this formula, Q equals to NE. Do you know this formula, right?
Yes, sir.
This is called quantization of charge. So plus minus NE. Now if I write in words the electric charge is always additive. That's what we wrote above. It's multiple of Okay, spelling wrong. Least amount of charge. Okay, so what is least amount of charge? E. What is the value of E?
1.6 into 10 to the power of minus 19
Yes. Minus 19 Coulomb.
coulombs.
So it is the integral multiple of least amount of charges. Done? Shall we go next?
Yes, sir.
Then last topic of this one. Shall I scroll, right? Is there anyone writing?
So one
Yes, sir.
second.
Sure. Yeah, sure. I'll wait. No text screenshot, you can write it. I'll wait for it. Once completed, tell me.
Done.
Done? Achha. Next is invariance of charge. Now, I'll go with some simpler words, simple terms. For invariation means like it's like mass. You know about mass, right? Like simply if I give you like this, they increase simply. Like if in one system it will be same, okay, it will never be like changing. It just mass depends upon what? The gravitation acceleration, right? Is it depending on gravitation acceleration, or mass will be constant throughout? Mass is constant, or it will be changing according to gravitation?
Mass is constant.
Yeah, so mass is constant throughout, right? Exactly. A similar way, charge is also a constant everywhere. It is just depends upon some object. Now, what type of charge it is having, how it is having. So it is just a term, this one, like it is just like mass. For a closed system, charge varies, or we can say not varies, it's invariant of speed. Okay, do you know this meaning of this invariant? VA, okay, it's not E, it's A. Spelling wrong. Invariant. Yes, invariant. What do you mean by invariant? Variant means variable. Invariant means never change. Simple. Charge is invariant with speed. Even mass. Mass is also never changing. Let it be whatever acceleration due to gravity. Okay. So whatever speed of light or whatever speed it is, even the speed, whatever speed increase, like 3 into 10 power 8 also doesn't matter, but charge will be invariant. So underline this word, underline this, invariant. Charge is invariant of speed, never change. If you want to write here, never change. Okay?
Yes, sir.
Okay, fine. The last is unit, then we can end our class. Do you have any other class after this? I think so. There is a maths class, right? Do we have maths class now?
No, sir.
No?
Yeah.
Okay. What is unit of charge?
Coulomb.
Yeah. That's what we started in the first topic, right? This was our first topic, I think so. Yeah.
Yes, sir.
So who discovered this one? What was his scientist name?
Charles Augustin de Coulomb.
Super. So you remember that.
Yeah.
Or you wrote in your notebook.
No, sir. Remember also.
Super. It's okay. Like if you're written, it's great. Doesn't matter. Yeah, this is not your exam.
Yes, sir.
Okay. Okay, guys. See you next class. We will have some quiz on next class. So be prepared with this one.
Okay, sir.
Yes, sir.
Yes.
Actually, I was about to do today, but as our topic was going on, so I don't want to stop the topic.
Okay.
So
Yes,
do you all have accounts on that quiz app, right? Quiz.com?
Yes, sir.
Okay,
Yes,
super.
sir.
This.com.
Yeah.
Yes, sir.
Oh, okay. It was too okay. Strong. Fine. Okay, guys. See you on next class.
Thank you, sir.
Bye, sir.
Thank you, sir. Bye, sir.
Bye-bye. Bye.